Good evening to all. I will start the session. Before going to the today's session, first we will discuss what happened in the last session. In the last session, our main topic is related to data types. First of all, what is mean by data type? Data type means simply the type of information stored in a variable. Now, Python is dynamically typed language. I already shown the difference how a variable is declared in C language and in Python. So, C language, before using the variable, first you need to declare the variable with the particular type. Then only it is possible to use. Then only it is possible to use. But coming to Python, Python is a dynamically typed language, means no need to declare the variable in advance. Based on the type of the value, the variable takes such value. I already shown in the example in the last session. Along with we discussed different data types. Under this, some basic data types also included. Int, float, complex for storing the numerical values, boolean, that is bool, bool, which is used to store the values of true and false. After that, we discussed string, list, tuple, dictionary set. I already said just those are introductions. We have complete in detail of string, list in the last sessions. Okay, these are the things that happened in the last session. Now, in this session, I will share the screen. Okay. Now, in this session, we will discuss the concept of operator. Discuss the concept of operators. This also plays very crucial role. What is mean by operator? Operator is simply a symbol which is used to perform some operation. A symbol used to perform some operation. We have different types of operators. First one is arithmetic operator. I will move one by one with program also. From today onwards, we will discuss each and everything with program. First one is arithmetic operator. So arithmetic means our regular mathematical calculations. What are those? Plus means addition, plus is addition, minus is subtraction, star, here star represents multiplication, star represents multiplication. Okay, everyone know these three: addition, subtraction, multiplication. Next, slash, this one represents floor division. Double slash. So double slash represents floor division. Single slash. Single slash represents just division. Percentage. This is also division. Anyway, I will explain each and every one. Finally, double star. Double star means power. What is the meaning of this one? Understand carefully. I given any two numbers 2 comma 3, any two numbers, or else consider the number 10 comma 3. 10 comma 3 are my two numbers. Now, how do we perform operation? If you are writing a program is 100% you need to know operators. Without knowing the concept of operator, it is not possible to write a simple program also. Okay, 10 plus 3, addition is performed. The result is 13. 10 minus 3, the result is 7. 10 into 3, the result is 30. Everyone know all these three. Now, I will move to last one. 10 double star 3. 10 double star 3. Internal meaning is 10 cube. I think you got it. 10 cube. The answer is 1000. The answer is 1000. Now coming to these two. These three symbols are used for division only. These three symbols are used for division. Whenever we are perform division operation, the result is either a quotient or remainder. Yes or no? The result is either a quotient or remainder. You are performing the division operation like this. In our school days, you are performing the division operation like this. How? 3 3s are 9. Remainder is 1. This is one way. This is one way of division. Another way of division is 3.3333 and so on. 10 0 after some particular point, after some particular decimal point, the number division, most probably 3.3333 and so on. In the last digit we written as 4, the last digit we written as 4. Okay, or else suppose take another number 9 comma 2. One possibility is 2 4 jar 8, the remainder is 1. Another way of division is 2 4.5, remainder is 0. Now observe, first I will explain this one. Division, the result is a quotient, always it performs the exact multiplication. Always it performs the exact multiplication. That means 9 by 2. What is the answer? The answer is 4.5. Even though you already know 9 is an integer, 2 is integer. You already know what is an integer, whole numbers. Even though numerator and denominator both are integers, the result is exact multiplication, sorry, exact division. The answer is 4.5. Now 9 double slash 2. Here the numerator is integer, denominator is also integer. Here both are integers. The result is also an integer. Remember the floor division. What is mean by the term floor? I think in mathematics everyone know the term floor. If anyway, if you don't know, I will explain. See this one. For example, floor of 3.6. The answer is 3. I think everyone know the round function. Suppose I given a value 3.6. What is the round of 3.6? 4. Above zero point 0.5 next number, below zero point 0.5 below number. But coming to floor operation, floor of 3.6 always below integer. Suppose floor of 3.9. The answer is 3 only. Floor specifies the below integer. 9 double slash 2. The answer is 4 only. You got my point? 9 double slash 2. The answer is 4 only. It performs integer division. Now, single slash and double slash are used for getting the quotient value. Used to get the quotient. Now, percentage is used to get the remainder. Now, 9% to what is the answer? 1. Think you understand, sir? 9% to if this division is performed, the remainder is 0. If the remainder is 0, there is no use. Always we are getting the remainder if the numbers are divisible as floor division. So 9 divided with 2, we are getting quotient as 4 and the remainder is 1. These are some regular arithmetic operations. Arithmetic means some normal mathematical operations that we are performed. Now I will open IDLE, click on IDLE. Now check step by step. 10 plus 3. The answer is 13. In Python, this is the advantage. Interactive. Directly we can give the input, we can get the output. 10 plus 3 addition, 10 minus 3 subtraction, 10 into 3 multiplication, 10 double star 3, double star means power, double star 3 means power. Now 10 by 2, 10 by 2. Answer is, observe what is the answer? 10 by 2. We know that, sir, 10 by 2, 2 5s are 10. Very good. But if you are using single slash, that is, answer is quotient, always the result is always the result is floating point. The result is floating point. Floating means decimal point. Now here what is the answer? 10 by 2. The answer is 5.0. Even though it is 5, the answer is 5.0. You got my point? Now 10 double slash 2. Answer is 10 double slash 2, 5. Now 9 by 2. 9 by 2. 9 is an integer, 2 is an integer. Both are integer also, no problem. The result is always float. 4.5. 9 double slash 2. The answer is 4 only. Double slash means floor division. 9 percentage 2. Percentage means remainder. If you are dividing 9 with 2, the remainder is 1. Okay? You understand? These are the basics. Now, I will extend some more. 9.0 or 9 point some 2, whatever it is, slash 2. Actually, you know that double slash, the result is always integer. But here either numerator or denominator, at least one is the floating number. If at least one is the floating number, the result is also float. But everyone remember, but always point 0 only. It performs the operation like this. It removes whatever the point here. 9 double slash 2. The answer is 4. In the numerator, we have point 0. Simply it has point 0. Clear by point? Numerator, denominator, both are integers. No doubt, the answer is also integer. But here the thing is, if at least one is the float, it performs the normal division. Whatever the logic of double slash, the same thing is applied. But in the result, it adds point 0. Now, 9.2 percentage 2. What happened? 2 4 are 8. What is the remaining value? 1.2 is the remainder. You got it? 1.19999 so on. 3. Stop. This is the remainder. Now you got it? These are the arithmetic operators. Plays a very crucial role in any program. Next, move to second operator. Second one is relational operator, also called as comparison operator. Relational operators are also called as comparison operators. What are the different relation? Everyone know this one also. Everyone know these operators. What are those? Greater than or equal to, less than or equal to, not equal to. These are different relational operator. What is the output? Suppose if you are performing arithmetic operation, according to the value, according to the symbol, we are getting some output. Coming to relational, I given one question to you. Is 5 greater than 3? Your answer is yes or no. Your answer is yes or no. If you are doing any comparison, the result is yes or no. In technical term, the result is true or false. That means the output of relational operator is Always boolean. Always boolean, that means either true or false, either true or false. I think you know the remaining things. 5 greater than 3, condition is true, so the output is true. Greater than or equal to, less than or equal to 5 equal to 5 means both the values are equal, the output is true. 5 not equal to 4, condition is true or false. Here we are using those are not equal, those two are not equal. Yes, exactly, those two are not equal, that is true. Okay, now I will move to examples. Take any numbers. 5 greater than 3, the answer is true. 5 greater than or equal to 3, the answer is true only. 5 less than 3, answer is false, the condition false. 5 less than or equal to 5, yes, 5 less than or equal to 5, condition is true. 5 equal to 5, yes, two values are equal. 5 not equal to 5, the answer is false. Actually 5 equal to 5, but you are writing 5 is not equal to 5, the answer is false. Now you observe, what is the output of relational operator? Either true or false. This is used to compare different variables in your program. Used to compare different variables in your program. Next, move to the third one. The next operator is logical operators. The next one is logical operators. We have three logical operators, A and D end. This is the name of the operator. A and D end is the name of the operator, or and then not. We have three logical operators, and, or, not. The logical operators applied between the booleans. Boolean means true or false. The logical operator apply between the booleans. In the simple sense, if you are checking more than one condition, understand carefully. I given three numbers to you, A comma B comma C are the three numbers. Now what is your question is, check whether the number A is greater than B and greater than C. What is your question? Again I am repeating. Check whether A is larger or greater than B and C. Generally, how do we are checking? First we are comparing A greater than B. Yes or no? First we are doing A greater than B. Yes. This condition is true. If this condition is true, next you are checking A greater than C. If this condition is also true, then you are saying that A is the largest value. A is greater among B and C. You got it? So here in between, you are using AND operator. Now you understand AND. AND means if both the conditions are true, first condition is true and the second condition is also true, the result is true. Generally, it applies between some relational expression. The output of each relation is a boolean. Here first you are performing A greater than B. Suppose assume it is true and A greater than C. Assume, just for example, assume this is also true. Now the output is true. Okay, consider any two expressions, two values. What are the possible cases? True, 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 false, false, true, false, false. Yes or no? Here take two expressions. What are the possible cases? True and true. This one is true, this one is also true. Suppose this is true, this is false. This is false, this is true. This is false, this is also false. Yes or no? if you have two expressions and we have two values, true or false, 2 square, total 4 combinations. If you have three expressions, 2 cube, total 8 combinations are there. Now, if these are the four values, if you apply end like this, end if you apply like this, if both are true, the result is true. Both are true, the result is true. T and F, answer is false. F and T, answer is false. F and F, the answer is false. That means by using this one, you understand. End means if both the conditions are true, the result is true. If at least one is false, if at least one is false, the result is false. The result is false. You clear the point? You clear the point? Now, OR operator. OR operator, OR in our general meaning, if either one is true, if either one is true, so true, if at least one is true, the result is true. True, false, the answer is true. False, true, the answer is true. False, false, the answer is false. End means both the conditions are true, we are performing end operation. Both the conditions are true, if you are performing end operation, the result is true. In the remaining all cases, the result is false. Coming to OR operation, if at least one is true, the result is true. If at least one is true, the result is true. Now, not means simply only one expression it will consider. Here what is true? Not means false. True, false, false, true, false, true. I think you understand. If it is expression is true, not of the expression is false. Anyway, I will show you with example, then you will get the complete idea. Suppose take some value a comma b comma c is equal to 2 comma 4 comma 3. Right now I am taking three values 2, 4, 3. Now check some conditions a greater than b and a greater than c. The condition is false. How? First it checks a greater than b, 2 greater than 4. Condition is false. If at least one is false, no need to evaluate. If at least one is false, the answer is false. Suppose b greater than a and b greater than c. Check this one. B is greater than a, yes. 4 is greater than 2 and 4 is greater than c. The answer is true. The answer is true. Now, not of. Suppose B greater than A and B greater than C. Actually, here what is the answer you are getting? You are getting true. Not of true means false. So, not of true means false. So, the situation is if you want to check more than one condition, depending upon the condition, you need to evaluate some particular type of statements. In that situation, the logical operator plays very crucial role. Logical operator plays very crucial role. Now, the next one is a simple one. Assignment operator. Assignment means we already know, up to now we are using this one only. Is equal to. Is equal to means assignment operator. A is equal to 5. Simply 5 is assigned to A. Suppose A is equal to A plus 1. That means first the right side value is evaluated. Whatever the expression available right side to the is equal to, that expression is evaluated and the value is assigned to A, left side variable. First A value 5, A is equal to A plus 1. Now A value becomes 6. Now that 6 is assigned to A. That 6 is assigned to A. This is the simple assignment operator. Now I am moving into next operator. Up to now what we discussed, arithmetic operator, relational operator, comparison operator, and then assignment operator. Up to now you have any doubt? Four types of operators. Up to now you have any doubt? Ask me. So I got one question. What is the difference between Boolean and relational? Remember, relational is the operator. Relational is an operator. If you are performing some operation, we are getting the output as true or false. That true or false is called Boolean data type. So Boolean is my output result. Boolean is my output result. Relational is an operator. Relational is an operator. Okay. Now we discuss four operators. These are the four operators that we are using regularly. So in the most of the programs, the most of the programs we are using these operators. Okay. Now I will move to some additional operators also. I will move to some additional operation also. So give me 1 minute. 1 minute. I will start in 1 minute. Okay. Mm. Next to operator is bitwise operator. Next to operator is bitwise operator. The name specify bitwise. If you want to know this one, you have some previous knowledge also. I will explain what is the prerequisite for knowing bitwise. Okay, and I have one variable a. Assume it consists of a value 5. Remember, this is high-level programming language. You already know how a computer stores the value. Not only value, everything is in terms of binary. Yes or no? Computer can understand only mission language. Mission language means binary language. Every instruction is in the form of zeros and ones. Like this value is also stored. This value is also stored as the binary. Each and everything has some memory is allocated. Yes or no? Without memory, where the value is stored? Without memory, where the value is stored? So some memory is allocated. For example, assume here 2 bytes of memory is allocated. Byte means, I think everyone know. Anyway, I will explain. 1 byte is equal to 8 bits. 1 byte is equal to 8 bits. For example, your system allocates 2 bytes of memory for storing the variable a. 2 bytes in the sense total 16 bits of memory is allocated. Total 16 bits of memory is allocated. How? 0, 0, 0 and so on. 0, 0, 0. These are total 16 bits. Now, within that memory, what is the value 5? What is the binary representation of 5? This is not related to our program. Anyway, the binary value of 5 is 101. Anyway, I will explain after. The binary value of 5 is 101. So, 101 and the remaining are 000. So total 13 zeros and 3. For example, assume if your number is some 11 or if your number is some 12. What is the binary representation? 1101, 00 and 00. So total 12 and this is 4. Generally, we know that for our decimal number, left side we are placing 0, there is no use. Left side we are placing 0, no use. Similarly, this is my number. Left side, that is remaining spaces are filled with zeros. This is my number. Remaining spaces, the left side filled with zeros. This is called bitwise representation. Each and everything is called a bit. Each and everything is called a bit. Now you understand how the variable is stored inside the memory. Now move to the operation. The first operation is bitwise end. The operation is bitwise end. What is the operator? Ampersand. The symbol name is ampersand. Like plus 2 addition, plus is used for addition. Like this, ampersand is the name of the operator used to perform bitwise end. So, if the values are 0, 0, 0, 1, 1, 0, 1, 1, only 4 combinations, yes or no? You have two possibles, either 0 or 1. Suppose your numbers are a comma b. Assume you have two variables a comma b like this. The two possible combinations. Now, if you are applying A and B, and is bitwise. In this situation also, if both are 1, the result is 1. 1, 0, 0, 0, 1, 0, 0, 0, 0. Like both are true. Generally, in the programming, generally one is considered as a true, 0 is considered as a false. One is considered as a true, 0 is considered as false. Now, A and B. Next, second operator is bitwise OR operator. Bitwise OR operator. The symbol name is pipe symbol. Observe in your keyboard above the enter button. Above the enter button, you have one symbol, that is pipe symbol. Now A or B. R means you know that one. 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. If at least one is true, the result is true. If at least one is true, the result is true. And the third operator is bitwise XR. Bitwise XR. The symbol is cap symbol. The symbol is cap symbol. In your keyboard above the letter 6, for letter 6, cap symbol. Now A cap B, what is the output? This is very simple. Here two bits are same, 0, 0, 1, 1. The answer is 0, 0. If both the bits are same, the result is 0. If the bits are different, 0, 1, 1, 1, 0, 1. Okay, anyway, I will explain with one example. You will get the complete idea. Take any two numbers. Suppose A is equal to 5, B is equal to some 6. A is equal to 5, B is equal to 6. Perform the operation. First 5 is converted into binary 101. 6 is converted into binary 110. Now first operation A and B. What is the output? Like this. Bit by bit. Bitwise means bit by bit. 1, 0, 0, 0, 1, 0, 1, 1, 1. You got it? If both are true, 1. Remaining cases 0. A or B. A or B. 1, 0, 1, 0, 1, 1, 1, 1, 1. Or means if at least one is true, the result is true. Finally, A XOR B. XOR, both the bits are different, the result is 1. If the bits are same, the result is 0. 1, 0, the answer is 1. 0, 1, the answer is 1. 1, 1, The answer is 0. Like this, the operation is performed bit by bit. Anyway, it performed bit by bit and the result is shown in the normal number format, that is normal decimal number format. Now, what is the decimal number for this? 4. This is 7. This is 3. Sir, how you are writing means very simple. I will explain. See this one. Generally, 324. How can you say that the number is 324? Generally, this is a decimal number. Decimal number means base 10. Decimal number means base 10. We know that one. This is the unit position. This is the tens place. This is the hundred place. Originally, this one. Yes or no? 3 into 100 plus 2 into 10 plus 4 into 1. Yes or no? This is the original mathematical calculations. Like this. This is at unit position, 10 power 0 position, 10 power 1 position, 10 square position, 10 cube and so on. This is our regular number. Binary means 2. Binary means 2. Now this is 2 power 0, 2 power 1, 2 square. Any doubt? Calculate 2 square. Here also 3 into 10 square. 3 into 10 square plus 2 into 10 power 1 plus 4 into 10 power 0. Now 2 square, that is 4 into 1 plus 2 power 1, that is 2 into 0 plus 2 power 0 means 1. 1 into 1. What is the answer? 4 plus 1? 5. You got it? This one again I will explain. 2 power 0, 2 power 1, 2 square. So 1 into 2 square means 4. 1 into 2 power 1 means 2. 0 into 2 power 0 means 0. The answer is 6. This is the way. If it is a decimal number, 10 powers. If it is a binary number, 2 powers. Now I will explain these three operators. Check whether A is equal to 5, B is equal to 6. First A ampersand B. We are getting 4. Check A ampersand B. We are getting 4, right? Now, A or B, that is called pipe symbol. R is called pipe symbol. A or B, the answer is 7. Yes. A X or B. A X or B, the answer is 3. That means you are doing the correct calculations. These are three bitwise operators. Three bitwise operators. Bitwise endu, bitwise aru, bitwise XR, not completed. I will give you the most important two more bitwise operators. First one is left shift operation. Everyone follow this one carefully. Second one is right shift operator. Left shift operator, the symbol is double less than is the symbol. Left shift operator, double less than is the symbol. Right shift is double greater than is the symbol. Double greater than is the symbol. What is the syntax? A left to shift n. This is one example. A means my variable, left shift means moving the bits. Shift means shifting the bits, that is moving the bits. Left to shift means moving the bits to the left to side. Moving the bits to the left to side. Right shift means moving the bits to the right side. Yes or no? Now A double less than n. In that variable A, the bits are left shifted by n number of times. The bits are left shifted by n number of times. Suppose assume A is equal to 5, n is equal to 6. That means what is my intention? The 5 is left shifted by 6 times. Anyway, see this one. First to write down the binary representation of 5. This is my 5. This is my 5. Actually, left side we have zeros. Any problem if you move to the left side? No problem. Simply you are moving to the left side. 1, 0, 1. Observe the case. This is the position 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5 and so on. Yes or no? And so on. Now, first time, this is my original number 5. First to perform first left shift operation. The bits move to the left side. In the simple sense, 2 square position bit 1 moves to 2 cube. 2 power 1 moves to 2 power square. 2 power 0 moves to 2 power 1. Now what about this one? The empty position is filled with 0. One shift operation is completed. Perform second shift operation. 1 0 1 0. Now this position is filled with 0. Next shift operation 1 0 1 0 0 0. Next 1 0 1 0 0 0 0. How many? 1 2 3 4 are completed. 1 0 1 1 2 3 4 1 2 3 4 1 2 3 4 5. Finally 1 0 1 1 2 3 4 5 6. My shift operation is completed. Simply it is very easy. What is your number? 5. How many number of times I want to shift? 6 times. Simply 101 add 6 zeros completed. No need to do all this blind procedure. Simply place 6 zeros completed. Now observe what is the decimal number. This is the decimal number 10. This is the decimal number 20. This is the decimal number 40. And this one is 80. Anyway, you do the calculations, you will get the same answer. This is the number 160. This is the number 320. Observe the pattern carefully. If we observe the pattern, initially my number is 5. For one left shift operation, my number becomes double. Next shift, 10 becomes 10 double 20, 20 double 40, 40 double 80, 80 double 160, 160 double 320. Why? Observe carefully. 2 square position moves to 2 cube position. That means we are incrementing, multiply with 2. Yes or no? First 2 square, 2 cube means we have one additional. 2 cube means what is 2 cube? 2 cube is equal to 2 square into 2. That is whatever the position of 2 square is multiplied with 2. That means that is the reason 5 into 2 10. In the next shift 10 into 2 20, 20 into 2 40. For every left shift the value becomes double. Remember the point. Now coming to the right shift operation. So A right shift N. Now you understand. The bits move to the right side. The bits move to the right side. Consider your A value is equal to 320. For example, N is equal to some 7. So that means I want to perform 7 right shift operations. First to write down your number 1 0 1 1 2 3 4 5 6. This is my number 320. Right shift means the bits move to the right side, but right side there is no place. Left side means we have empty places, that is 0. Simply we are moving to the left side, there is no problem. But right side there is no place. So what happened? We lost the bit. Simply 1 0 1 0 0 0 0 and 0. We lost this bit. Simply for every right shift operation we are losing the rightmost bit. First shift is completed. Second one 1 0 1 1 2 3 4. Next 1 0 1 1 2 3, 1 0 1 2 2, 1 0 1 0, 1 0 1. How many completed? 1 2 3 4 5 6 1 0. 7 shift operations are completed. Anyway, you understand what is this one? This is 320. This one is first shift operation 160. Next shift 80. Next to 40. next to 20, next to 10, next to 5, next to 2. Understand, not point 2. The bitwise operators apply on integers only. You got my point? The bitwise operators applied on integers only. Even though you are dividing 5 by 2, the answer is 2.5. That is 2 only. Simply, if you are performing right shift operation 7 times, remove 7 bits. Anyways, or this is very complicated. For example, one number is given 242, left shift by 5 times. So the problem is, first you need to write 242 into binary and then add 5 zeros, again converted into decimal. Instead of that one, you have a simple formula also. The formula is, what is your variable? A into n number of times. For each and every time value is double. That is the reason A into 2 power n. You are getting the answer directly. If you have any doubt, check. What is my number? 5 into 2 power 6. 2 power 6 means 32. 32, sorry, 2 power 6 means 64. 2 power 6 means 64. 64 into 5, 320. You are getting the answer directly. So here, this case, simply 242 into 2 power 5. 242 into 32, you are getting the answer. For every right shift operation, what is the formula? A divided by 2 power n. A divided by 2 power n. Suppose A value is 320. 2 power 7. 2 power 7 means 128. The answer is 2 only. You got it? These are left to shift and right shift operation. Anyway, I will give you this example also. A is equal to some same number 242. A left to shift by 5 times. See this one. If you have any doubt, check this one. 2 power 5, 32. 242 into 32. We are getting same answer. Yes or no? Now, A right shift by 5 times. That is 242 divided by 32. This is the answer. 242 divided by 32. Same. So these are left to shift and right shift operators. Those are finally bitwise operator. Next, we have two more operators are there, and these two operators are especially available in Python. Up to now, whatever the operators we are discussed, those are available in C, C++, Java also. But I am going to discuss two operators. First one is membership operator. First one is membership operator. We have two membership operators. One operator name is in. One operator name is in. Second operator name is not in. That means the purpose of this one is, for example, you already know a string. S is equal to welcome. S is equal to welcome. This is a string. Now my aim is to check whether a letter C is available in the string or not. Instead of searching letter by letter, is C equal to W? No. C equal to E? No. C equal to L? No. C equal to C? Yes. Instead of blindly checking letter by letter, this membership operator directly checks the what is the output. In means, if your required letter is available, the output is true. If it is not available, false. Member. If your letter is a member, answer is true. Not a member, the answer is false. Not in means, for example, K, not in S. What is the answer? Here I mentioned a K is not in S. Yes, K is not present in S. The answer is true. C, not in S. What is the answer? The answer is false. Why? Actually, C is present. Now you got it. Membership operator means instead of blindly checking whether a letter or not only a letter, whether a substring anything available or not, we directly use the membership. Suppose S is equal to welcome. Now check K in S. Is K is present in S? No. The answer is false. Now L in S. Yes. L is present in the string S. The answer is true. Now K not in S. Exactly. K is not present in S. The answer is true. K not in S. Sorry, not K. Take some letter L. But actually L is present. Here I am using not in. So what is answer? Answer is false. This is membership. Not only string, you can use anything. For example, L is equal to 11, 12, 13, 14. You already know. Set of elements that are placed within square bracket. That is a list. Just you know the term. Now, 11 in L. Yes, the answer is true. These are called membership operator. How many? Two membership operators. One is in, second one is not in. Last and the last one is identity operator. Identity operator. We have two identity operators. One is, second operator is not. These are the names of the operators. Is not. Here, what is the purpose of innu not in? Checking the membership. Checking the membership. The purpose of this is to compare addresses. To compare addresses. Before explaining this one, I will introduce one more method, one more function, id. Id of, this is a function which is used to get the address. That means in which memory location your variable is stored. To get the address, we are using id. Now take one example. A is equal to 3. ID of A. See this one? In your system, at this memory location, this is address. You have some house number exactly? Exactly. In my system, in this memory location, my variable A with a value 3 is stored. In your system, the address is changed. The address is depending upon the system. That is called address. Suppose B is equal to 5. ID of B. This is also address. This is also address. Now A equal to B. Here what we are doing? We are comparing. Yes or no? Remember, here you are comparing the values present in A with the values present in B. Here you are comparing the values. Output is true or false? Yes. So A value 3, B value 4. But is operator is used not the values to compare the addresses. A is equal to B. What is the output? The output is false. The output is false. See this one? A is B. Here what I am doing? First idea of A, I am getting the address of A. Next to idea of B, I am getting the address of B manually by observing the two addresses. Okay, I fix that. So two variables have different memory locations. Instead of doing like this, directly you can write A is B. The address of A is not equal to address of B. In this situation, the answer is false. A is not B. Yes, the address of A is not equal to address of B. The answer is true. Final question. I think you understand. Is used to compare the addresses. Generally, in your mind, you have some question. What is that one? Sir, always different variables store different memory locations. different variables stores different memory locations. Always the addresses are same. What is the reason for comparing once again? Yes or no? For that, I will give you one basic conclusion. Anyway, if you know the complete concept of string and list, you will get the complete idea. Right now, I will give you some basic point. See this one. First, starting a is equal to 5. Whenever I create a variable a is equal to 5, in Python, what happened? In Python, it checks all the memory locations. It checks all the existed memory locations. If any memory location is existed with a value 5 or not. Right now, right now, no memory location is existed. If no memory location is existed, then what happened inside the system? Some memory is created with a value 5 that is referred by a. Now, within my program, I do one more step. Suppose b is equal to 5. Again do the same thing. Is any memory location is created already existed with a value 5 or not? Yes, already it is existed. So instead of creating new memory, b also refers to the same memory location to save the space. To save the space, yes or no? This is in Python only. In remaining programming languages, even though same value, different locations. But what is the advantage of Python? For the same value, no need to use multiple locations. For example, in the future, you are changing the value of b. Suppose if you are changing the value of b, then what happened? No problem. You are changing the value of b. This reference is destroyed. Create a new memory b. In that 6 is stored. This a referred 5 is not updated. Just to reference. Anyway, I will show you. See this one. A is equal to 5. What is ID of a? This is the address of a. P is equal to 5. What is the ID of B? Yes, you got it. So both points to same memory location. Suppose here I changed my value. B value is incremented by 1. Now ID of B. See this one? Address of B is changed, but address of A is not changed. Address of A is not changed. A is B. So I think you got it. But final point, remember, suppose A is equal to 512, B is equal to 512, A is B. The answer is false. Here A value is 512, B value is also 512. Both you are getting 512. But both the same value means same address, but the answer is false. Now a is equal to 256, I will show you. B is equal to 256, a is B. Now observe, the answer is true. Actually, why 256, 5 to 12 means in powers of 2, up, depending upon system. Maybe in your system, A value 512, B value 512, A is B. This is true. Depending upon the system, it can take up to 2 power 8 or 2 power 9 or 2 power 10. It has up to that many values, same memory location is created. If the value is changed, suppose in my system from 257 onwards, so that means what is their intention? Small numbers means very little modifications. If the number is big means multiple combinations, that is multiple modifications are required. That is the reason they allotted separate memory. In my system up to 256 only you are getting the same memory. But anyway, right now it is not useful. It is useful when you are moving to the topic of string, list, tuple. There this is operator plays very crucial role. These are the operators that we are used in our Python. Now you are completely eligible for writing a program. From the Monday session onwards, you are writing the program also. That is the end of today's session. Any doubts? Please ask me.